Dear viewer, welcome to Indices Consultancy Services. Remember, in recent time we started a series called Laws of Indices, Part 1, Part 2, and Part 3. And this is a concluding part. Well, I've started in this concluding part that we are going to show that most examination bodies do not actually set a question that you will use only one word to answer. Yes, that's a standard question. Because of that, it's very good we show you how you can combine the laws and answer one question in exam. Whether it is objective question or is a theory question that needs showing what. Let's see. We look at the laws we have taken so far as law number 1, that x raised to the power a times x raised to the power b is given to be x raised to the power a plus b. I hope you remember this from part 1, part 2, part 3. Then 2 is x raised to the power a divided by x raised to the power b is equal to x to the power a minus b. Number 3, that x raised to the power 0 is equal to 1. And then number 4, that x raised to the power 1 over a is equal to a root. Whatever the a is, it will be a root of that x. Then number 5, x raised to the power b over a, which is again a root of that x. But this time around, all raised to the power b. We expect that b will be another number apart from 1. And so number 6 then is x raised to the power minus a, which is 1 over x raised to the power a, which you saw in part 3. Then number 7, x raised to the power a all raised to the power b being equal to x raised to the power ab, which was also seen in part 3. If we proceed further here, bringing 2 or more laws here can give us another derivation of more laws. But let us make use of this at the moment. Yes, we can make use of 2 or more of these to answer external question in examination. Example like that is what we have on the body here. Questions number 1, 2, 3, and 4. Let us try to answer them. If you look at the questions, you find out that actually one law may not be able to solve all of them. So we need all of them. Okay, let us start from number 1. Number 1 says simplify. Please note that the words simplify, evaluate, work are similar. And what it is telling you is to look at the question, the mathematical signs that is there that is telling you what operation is. Use that sign to know what to do, to know how we work it. And so we are going to solve number 1, which says we should simplify 8 raised to the power 2 over 3 times 27 raised to the power minus 1 over 3 all over 64 raised to the power 1 over 3. Yes, if you see this, the first thing we are going to do is to line them up. We line them up here means let us write them as 8 raised to the power 2 over 3 times 1 over, because of what we have seen here, 1 over 27 raised to the power 1 over 3. Before we have divided by 64 raised to the power 1 over 3 as well. Having seen this, we see that we still have a work to do here. We consider this whole number to be over 1, this whole number to be over 1, this whole number to be 1 over 27 raised to the power 3. Then our new work is going to be 8 raised to the power 2 over 3 times 1 over 27 raised to the power 1 over 2. Remember that 1 over 3. Remember that this is over 1. And this we can change to times 1 over 64 raised to the power 1 over 3. Yes. Now we can treat both the numerators and denominators according to what we see there. We can have it as this is square root of, okay, cube root this time around, cube root of 8 raised to power 2 over 1 times 1 over cube root of 27. We will not say raised to power 1 because it's going to be the same thing, times 1 over cube root again of 64. We will also not say raised to power 1. Then what do we have? Cube root of 8. Here is 2. Then raised to power 2. Raised to power 2 over 1 times 1 over cube root of 27 is 3. There's no power to raise to. Times cube root of 64 is 4. The cube root of 64 then is 4. Remember how it goes? As we don't know what to do, there is 64. 2 will give us 32. 2 will give us, as we were using 2. 2 we get 16. 2 we get what? 8. 2 we get 4. 2 we get 2. 2 we get 1. Remember, any number that appears 3 times, we give it as 1 because at the time of cube root. And then 1, 2, 3. Give us 2 as one of the numbers. 1, 2, 3. Give us one of the numbers. And 2 times 2 is what? 4. That's why cube root of 64 is 4. And now we have it as 4 over 1. Yes, 4 over 1 times 1 over 3 times 1 over 4. I think you see it is very wise to just say 4 divided 7 to give us 1 here. And we have 1 times 1 times 1 will give us 1 over 1 times 3 times 1 will give us 3. And the correct answer to this number 1 question is 1 over 3. I hope it is very nice. Alright, if you understand something then, let us move to question number 2. Question number 2. In question number 2, we have equation. How do we know that it's equation? One, we have a letter there. And not only that we have a letter, we have unknown to be solved. We have equal to sign. Showing us we have left hand side and right hand side. That means we are going to get it to be 2 raised to power 5x divided by 2 raised to power x being equal to the 50 roots of 10 of 2 raised to power 10. Let us make the necessary changes that is required of this. To start with, the law of indices says we should pick 1 here on the left hand side and say 5 raised to power x minus x. Yes, and that is equal to, because we use the laws we have here. Laws we have here, and say that we can write this as 2 raised to power 10 over 5. Remember, if you are given this, you are going to say 5th root of 2 raised to power 10. So we're taking it back now. So that what we're going to have here is 2 raised to power 4x being equal to 2 raised to power, when we divide this we have 2. Oh yes, so can we see here, the bases are now equal from the left hand side, right hand side, and so the indices are going to be equal. So we cancel out the bases and say that 4x is equal to 2, and then x is equal to 2 over 4. 2 over 4 gives us 1 over 2. Half as the correct answer to question number. This question here is question number 3. And question number 3 says we should evaluate 5 raised to power 5x raised to power 2 times 4x raised to power 0 times 2x raised to power minus 6. Yes, remember that in this question here, the 2 here is only for this x. The 0 is for this x alone, and the minus 6 is for this x alone. If it is not for this x alone, we have bracket to show that everything is involved with the power. Alright, so it's very good for us now to separate them, since we can see that we cannot actually have the same base for the number. We write that 5 times x raised to the power 2 times 4 times x to the power 0 times 2 times x to the power minus 6. Yes, we can write it as 5 times 4 times 2 times x raised to the power 2 times x raised to the power minus 6, or 1 over x raised to the power 6, as you know before. And so, in this case, we can have, assuming we leave it as x to the power minus 6, we are going to have 5 times 4 is 20, 40. So we have 40x now raised to the power 2 plus minus 6. And that is 40x raised to the power 2 minus 6 will give us minus 4. And eventually, the answer from this simplification is going to be 40 over x raised to the power 4. This is going to go down below because of the law of indices. That's question number 3. Finally, the question number 4 here. Question number 4 here is a question that sometimes many books do not actually prefer to call it equations of indices or indical equation, but exponential equation is a little bit higher than these ones. And what do we do about it? Create a system that will accept all the bases here. And so we have 3 raised to power 2x plus 1 minus 28 raised to power, 28 into 3 raised to power x minus 1, before we say it's equal to minus 1. Alright, we have seen 3 raised to power a number here, so we try to work on that. And so let us have it as 3 raised to power x into 2 times 3 raised to power 1. I think you know that when we go back, we'll get back to this. Yes. And so we have minus 28 into 3 raised to power x divided by 3 raised to power 1. We can say plus 1 is equal to 0. We are doing this because we see a quadratic equation trying to come out. And so let us see here. Let's 3 raised to power x be equal to p, for instance. If it's equal to p, anywhere we see 3 raised to power x, we put p. And here we're going to put p. We have p raised to power 2 times 3, we have times 3. So minus 28 into, here we have p again, divided by 3, that's going to be p over 3, bracket closes, plus 1 being equal to 0. Alright, what do we have now? We are going to have it as 3p raised to the power 2 minus 28p over 3 plus 1 being equal to 0. Having seen denominator now as 3, the LCM of the denominators will become 3. This is over 1, this is over 3, and this is over 1. And so we use 3 to multiply each expression. Multiplying it here, we are going to have 9p raised to the power 2 minus, multiplying 3 with 3 here, we have 28p plus, multiplying by 3 here will give us 3 is equal to 0. When we multiply 0 by 3, we still get 0. Yes. So here we are going to multiply, work this question using any method of our choice, quadratic formula or factorization method. Let us use factorization method here. But by the first and last terms will give us 27p raised to power 2. Alright, so we find the two factors here, minus 27p squared and minus p squared. To multiply these two numbers, you will get this, of course. If you add it, you are going to get the middle term. And so we replace the middle term, which is going to be 9p squared minus 27p minus p squared. Yes. What we have here, that there's no squared here. And so we are replacing the middle term now. Plus 3 being equal to 0. By the time we get this now, all we are going to have is factorizing by grouping. 9p is here, 9p is here, we pick 9p out. 9p divided will give us p minus. 9p divided here will give us just 3. 3. Then we have minus 1 is HCF here. 1 into p minus 3 is equal to 0. So p minus 3 here is in the brackets. We pick 1. P minus 3 brackets 9p minus 1 is equal to 0. Is the factorized expression. Then p is equal to 3 or 1 over 9. Yes, but we have said before that what is going to be p is what? Remember that from here, let 3 raised to the power x be equal to p. So anywhere we see p, what is answering is 3 raised to the power x. And since the person asked us the question, the examiner did not give us anything about p, we introduced p by ourselves. We are going to get the x for him or her. And so we are going to say, then what does it mean? It means that 3 raised to the power x is equal to 3 raised to the power 1, which is one of the p's here. So if the bases are equal, then these are going to be equal. And so x is equal to 1. That's one of the answers to p. Or if it is not 1, we are going to have 3 raised to the power x is equal to 1 over 9. And that means 3 raised to the power x is equal to 3 raised to the power minus 2. Again, the bases are equal, then these are going to be equal. So x here is equal to minus 2. So the correct answer to the question here, called the root, is either x is equal to 1 or minus 2. Dear viewer, I believe from the laws of indices, parts 1, 2, 3, and this concluding part 4, has really taught you something in the laws of indices. Please comment, like, and share. Thank you very much until we continue with other episodes.